Hello, everyone. We are going now towards the working group 2 presentation about high altitude platform systems. This presentation will be given by Darshan Shridan and Gurav Namta. Hi, guys.
Hello.
Hi, everyone.
So whenever you want, you can start. The floor is yours.
Perfect. Thank you very much. So firstly, welcome to Working Group 2. Our presentation is pretty much in relation to the high altitude platform systems, also known as high altitude pseudo satellites, which some of you may know it as. Presenting here is myself, Darshan, and Gaurav on the video as well. And yes, supported by GMV as the supporter and the gold sponsor for the HAPS presentation we'll take you through. Next slide, please. So as part of our working group, we've structured our presentation with a whole bunch of input from several people. So Mafalda, Antonio, Gaurav, Lorenzo, Michalis, Loan, Abdul, and Alejandro, as well as Maria and Ivan as well, which has helped us guide the process. Throughout the whole last few days of putting this together, we've been supported by Miguel as our subject matter expert. And so presenting GMV, we've had a very rich content of information that we've applied throughout this presentation. But overall, we wouldn't be able to present what we have today without the contribution of every single person that has participated. Next slide, please. So the first question you're probably wondering is, what is HAPS? Or what is a high altitude platform system or a higher altitude pseudo satellite? Essentially, it's not a satellite. It's not out in the space itself. It's actually something that hovers around in the stratosphere, so about 20 kilometers upwards. It introduces a new paradigm or a new kind of way of visioning what you could kind of see our world to be. And what I mean by that is you might be picturing things like blimps and balloons and stuff, and that's kind of conceptually kind of what a HAPS satellite or a system actually is. It's something that does glide and fly around in the higher levels of the atmosphere. So you're probably wondering, and it still probably doesn't quite make sense, but why would we even consider this? Well, the fact that it's in our atmosphere means it's more stationary, it's more static in location, but we have a lot more control as to where it can go. Whereas a satellite will go in orbit, or depends on which orbit it's actually in, but the HAPS itself, it's a lot more controllable. Having said that, given that it is within the atmosphere, the proximity to the ground is actually a lot more, which means accuracy in terms of what it's imaging or what it's looking at, but also the lower end of latency issue. So it is much closer to the ground, so you're beaming the data back in almost real time. But now you're probably wondering how you're going to actually get it powered up there. Well, technically, we're closer to the sun, so solar power becomes a really good way to keep it energized and keep going. There are a couple of things which will come down to throughout the presentation itself, but that's kind of the strength points, as well as the fact that it can be a temporary structure. It can just go up and you can pull it down when you don't need it. There are two significant types of these. So some of these are known as HTA, so heavier than air, and they're the kind of gliders in design. Then you've got lighter than air, which are kind of your airships and balloons. And previously, you might have heard of Balloon, which is a attempt by Google to get these up. But it's a thing that's already happening. We've got C, we've got Thales, Airbus, Ultran, a number of different organizations that are looking to get something up there. Whilst they might not be 100% operational yet, it's happening. It's proof that it can actually happen. And just to blow your minds a bit more, these things are huge, 150 meters in size. You're not talking about a small drone that you can just go outside and play with. You're talking about a massive platform that can support a whole bunch of different activities. There are a couple of weaknesses, and it's really challenges that we need to overcome. So one being energy management. How do you keep it going in the stratosphere with the required energy without it dropping out of the sky? How do you operate with it on a day-to-day basis and also make sure that it's robust for your purposes? But also the fact that it's hovering, it's up in the air. How are you going to keep it hovering when you're using heavy metals? So really, you got to use lightweight structures and new age materials to really get it up there. Next slide, please.
Okay, so now that we have an introduction of what HAPS are, we are going to address 4 specific questions. And the first one is about how does it compare to the traditional options that are available? How does it compare with satellites, and how does it compare with terrestrial networks? So first, we are going to talk about satellites, and the three criteria would be economics, is it cheap or not, energy, and sustainability. So when it comes to satellites, comparing with satellites, I think HAPS is less expensive for the obvious reasons that you don't have to put it into low Earth orbit, and you don't need the amount and the financial backing for that. Also, because the equipments used for HAPS need not be space graded, because for the obvious reasons, because the equipments are not in space, so you can have cheap equipments for HAPS, and that why it makes economic sense as compared to satellite. Energy wise, also, if you see, you don't need a rocket ship or a launcher to launch it to low Earth orbit, because it's being launched at the distance of 20 kilometers. So in terms of energy, we don't need a lot of energy either. Also, in terms, if we see for communication through the data stations, you don't need that amount of energy, because the distance between the data stations and the HABs is relatively less as compared to a satellite, I suppose. And the third and the most important point, sustainability. It's always easier to build, to bring it back and maintain it. One of the most pressing issues in the space sector is about space debris and the polluting low Earth orbit. Well, guess with HAVs, you're not polluting the low Earth orbit, and we are kind of safe from the problem, and it's at an altitude where it's not too polluted. So it's better than traditional satellite technology. Next slide, please. But now we'll focus on how HAPS compare to terrestrial networks. Again, the three criteria remain the same: economics, energy, and sustainability. In terms of economics, it's as simple as that. Putting things up in the atmosphere of around 100 meters is far more economical than building large structure here on land. But in terms of energy, also, when things are on land, on terrestrial networks, there are a lot of barriers, and it's not so efficient. Well, guess what? When you have things on space at 20 kilometers, there are not so much barriers, and hence it's more energy efficient. And in terms of sustainability, we are saving a lot more land mass, because we are building these structures. We are deploying this structure up in 20 kilometers, so we save on land mass too, and there's no deforestation or stuff like that required for installing these hardwares. So again, we see the obvious benefits of using HAPS as compared to terrestrial networks. Next, please.
So you're probably wondering, why would we actually talk about this concept? Like, who's going to use it? Why are they going to use it? What can you really benefit from using these technologies? Well, the answer is there's actually quite a few. Similar in design to why you would use a satellite, but a lot more powerful and a lot more stronger, and green for the environment as well. And there's a number of different areas. One aspect of it being natural uses, and one being more like humanistic elements, which we'll get to as well. But think about, I guess, flora, fauna, and species protection. So the world, we're trying to focus on climate change. So this issue is quite important for us, right? So understanding not just, I guess, pollution levels, but also understanding what's happening from an illegal fishing and whaling perspective, making sure that you've got species that are meant to be protected or almost extinct, or monitored and made sure that they can still exist. Flipping the lens, then you've got predictive weather and natural disaster or recovery management. We've got tsunamis, we've got earthquakes, we've got significant kind of weather events these days, which usually result in telecommunication networks going down, or really just not having the infrastructure you need to be proactive or predictive. HAPS is a great combination where you can quickly flick this platform up for that temporary kind of network communication, so you can actually help whoever's been affected at that time of need. And so really that ability to launch something and bring it down when you don't need it anymore means that you're not wasting hundreds of millions of dollars trying to organize and get something up and running. And then you can flip the lens and go agricultural farming and crop cultivation. So not many countries have access to food like what the first world countries do. And so agriculture becomes quite important for these countries. So you're kind of looking at how you can get the best out of what you do have. And so it comes to optimized land use management, being able to have a HAPS system a lot more closer to Earth, given that it's a lot more accurate, you can start doing more powerful machine learning or trend analysis to actually see when you should do something, when you shouldn't do something, and it just forces that paradigm of let's just do what we can with what we have in a more accurate fashion. Next slide, please. But then you can flip the lens, and these are kind of aspects where we have more control. So not quite nature in element, but kind of more where the human civilization comes into it. We're trying to focus on smart technologies more and more these days. And you've got autonomous cars, you've got Industry 4.0, you've got smart city and Internet of Things. The world's moving that way. There's no real way that we're going to go backwards. We're going to keep going that way, which means we need faster internet connections. We need a low latency. We need higher bandwidth. We need more accurate kind of capabilities. And that's where the HAPS system comes into play. But it is, again, coming back to what we said at the start, it is lower to the ground, which means better connection, optimized, connected, and intelligent. But then also from a fire search and rescue perspective. So we quickly mentioned before where because it is lower, because it is stationary in nature, you have better coverage. You have more control of where it should go, what it should do. And it also gives that paradigm of, hang on, what can we do going forward? Maybe we could have drones that actually pour out water, or at least interface with different technologies to really get on the front foot of these issues. And talking about front foot, legal activity monitoring. Again, because it is lower, you could have it set up in points of interest on the borders, in suspicious areas where you think something's going to go wrong, or high security areas for surveillance. And that really tells you that because you do have more control, you can do exactly what you needed to do, and really put the human civilization on the front foot when it comes to a lot of these aspects. Next slide.
Okay, so now for any new technology to work, it's not only important to identify the applications and the use cases, but it's also to go down. It's also better to go down a bit deeper and think about how are we going to operate them. And for that reason, that's the third topic for our day. That how are we going to operate HAPS in terms of three criteria. First, will it be fully autonomous or will it be driven by human beings? Secondly, will it be seasonal or permanent? And third, and the third and the most important, who will be operating these structures that are hovering around at 20 kilometers? So we will cover just a few of them. For predictive weather and natural disaster and stuff like that, it will be fully autonomous, and it makes sense because for regular monitoring of the weather, or even to mitigate natural disaster, it does not make a lot of monetary sense or having human beings from data center control it. So it should be fully autonomous. It depends on the application, what we're trying to track, whether we're trying to track the weather or we're trying to track a particular natural disaster, the cyclone or something like that. It depends on that will it be seasonal or will it be permanently deployed? And the third, that it's quite obvious, it should be operated by the national government. Similarly, if you move below and see about flora and fauna, again, mostly things should be fully autonomous because that's we're living in the 21st century, and it does not make a whole lot of sense to it be driven by human beings. But these can be deployed ad hoc if required, and again, it should be operated by the national government. We move to the next slide and see what are the other activities that are there. Next slide, please. Yeah. So again, agriculture or smart technologies and fire search and rescue operation, most of them will definitely have autonomous operation. It should be autonomy, fully autonomy should be focused on. How they're deployed and how they're operated, seasonal or permanent, depends on the application. For agricultural crop farming, I guess it will be more kind of permanent deployment. For optimized smart technology, again, permanent deployment, whereas for fire search and rescue operation, it will be ad hoc deployment. Again, for agricultural farming, it should be operated by farmers and forest entities. However, for smart technology, it should be operated by the city level government, the municipality, the city regulated authorities. And for the fire and rescue operation, it is open. Like we have kept that open because it depends how much area that is being covered, and such operation. So it depends which authority is actually responsible for operating it. But we don't think that's the most challenging point. We certainly believe that it can be put to use. Next slide, please.
And you're probably wondering, everything sounds really positive. There's probably a negative slant here. Well, there isn't as much of a negative slant. There's a couple of challenges that we need to work through, and these are not only technical challenges, they're the humanistic challenges, they're certification challenges, which I'll talk through shortly. But they're areas that are quite, I guess, new in design, but people are working on it. As we mentioned at the start of the presentation, there are quite a few different players in this area, and so they all work together. And so these challenges aren't overcome, you can actually overcome them. It just takes some time and effort. But to go through these in detail, so from a technology standpoint, the fact that you need lighter structures, durable structures, and really, really strong energy management procedures for these things, it does pose a bit of a challenge. And I guess solar powers, batteries become quite important in making sure that the purpose of using HAPS remains green and efficient, because you don't want to cause the same issue as what we have out in space with space debris and everything that comes off of it. But this is an opportunity for us to stay green. So making sure the energy management is as optimal as possible becomes quite important. But this is an area that is still being researched, and it still needs funding for us to work out how we can better service this area. But then on the flip side, you've got a certification issue. The fact that these HAPS systems operate in the stratosphere means there is a risk that they will cross jurisdictional boundaries, which starts raising the issues of like national security, sovereignty, who owns this airspace, what are we doing about that? And really the major positives come off the back of everything in the space industry, really, is where we can share the technology across borders. And so certification becomes quite important. Making sure that you have the right certifications for the right countries, but also in that international kind of setting becomes quite important as well. But then you can almost flip that in two ways. The best case scenario is you probably have that international awareness that lets you do whatever you need to do. But then maybe you just need something more tactical. So maybe there's a specific purpose. You need to get up and running tomorrow because there's a disaster happening. Maybe you can get a temporary license, a lot more tactical in nature. But that is an issue that quite crops up in a lot of technology domains. So it's something that still needs to be updated and I guess work through with the international bodies. Maybe there's new regulations that need to come into play. Next slide, please. And then you've got public acceptance. So this kind of falls off the back of that prior point. Drones already cause a bit of an issue and concern for many people where they'll be flying overhead, but there's no person attached to it. The person could be miles or kilometers away. And so that starts raising like concerns about, is there someone spying on me? What's going on here? So privacy becomes a quite important part. And really working with the customer, working with the public, working with citizens becomes quite important to make sure acceptability of the HAPS platform is, we actually do get that. And that includes just communication exercises. That includes showing them that it can actually produce the results we actually want. But that will always be a bit of a challenge, but that is something that we can actually work through. After all, we've gone a long way in the space race since 1960s. And then on the opposite side, funding. As with most technology projects, funding is probably the most critical component. The solutions in design aren't the most easiest, which means a lot of funding needs to go into the R&D exercise because you want to make it profitable at the end of the day. Yes, it might cost a lot of money in the first instance, but you're talking about economies of scale that come off the back of this naturally once you can prove the concept works. And similarly, there's people working on that. So that helps really push this initiative forward. What really that means is grants become quite important. Talking to private equity investors, talking to governments for funding, partnerships with incubators or even consortium efforts actually become quite important to try to get this off the ground. After all, similar to everything else that's been happening in this century, yes, it does take a bit of funding to get things off the ground, but once it's going, it proves that there's a profitable business model that is off the back of that, especially when there's an environmental impact in play for Earth as a whole. Next slide, please.
Okay, then after going through the challenges, we want to conclude it on the positive note. The key advantages of HAP is that it's easier to deploy, it's cost saving, it's cheaper, and it's better for the it's sustainable. We are not polluting the low Earth orbit. A point to be noted that HAPS was a technology that people were quite excited about in the 2000s. in the early 2000s, and the US, the UK, and Japan actually used and invested a lot of it in the technology. But I guess we guess that the technology was not yet readily available at that point of time, and the enthusiasm faded. However, we certainly believe, having worked with expert from GMV, we certainly believe that now is the right time to invest in it. And if proper funding is available, this technology is here to boom. Except for two challenges. The first is uh, reaching that technological readiness level that we acquire a lot of funding. And the second, which is not really technological but kind of bureaucratic, is getting certifications. There is still no regulatory body for that altitude, for HAPS altitude. There are regulatory bodies for airplanes. There are regulatory bodies for satellites. But between that, where HAPS come in, there's still need to lay down proper regulations and rules and certifications. And so I think these two challenges, we certainly believe that for this, it should be solved in this decade. And the technology should rise up from here. And that's it from our side. Thank you so much for your attention, and do let us know if you have any questions.
Okay, thank you very much, Dash and Gurav, for that presentation, and also thanks to all the delegates that have contributed to this working group with their ideas. I propose you now, let's move to the questions that we have coming from other delegates. We have a first question about HAPS operation. Do you have an idea of how long could a platform like this stay in flight?
Maybe I'll take it, Darsh. So most of the operations that are taking place at the moment, or the project that are in pipeline, they are for about a year or so, because that way it makes economic sense. You're investing in technology, so that's the idea. For even whatever happened with the Google Project Loon, it was there for a year and so, and so somewhere around year, definitely. That's the idea.
Okay. We have a question about would HAPS require to strengthen the network of on-ground antennas to ensure continuous visibility for data broadcast downloading?
Yep, so I can take this one. So given that HAPS systems are kind of stationary in design, it helps with the data quality that needs to go back and forth. So in a sense, you're actually going to be able to work with the network a lot easier. Obviously, it comes down to what network and what frequency it's all built on as well. But you start actually getting better signals through that.
And you already mentioned that, I think, during the presentation, but people ask about certification, no, of these platforms. How can you demonstrate that it works? Which could be the strategies for certificate such a platform?
I think certification can only work when we have proved the economic viability of this technology. And I think it will go through military. I think any new technology like GPS, it goes through military. The technology is proven for military services, and for security services. And once it's proved, once it's easy to be deployed for commercial services, I think that's where the need for a regulatory body comes, and that's where the public awareness comes. So unless we reach that technological readiness level where it's easy to demonstrate, it's very difficult to push for a certification at the moment.
And we have talked about HAPS as a sustainable solution, but can actually these platforms contaminate as well somehow?
Technically, if we start thinking about the need for batteries, that is going to have a direct tie-in with, I guess, the sustainability aspect. Is batteries by design aren't always the most green, but that's where really using solar power and making sure you're using greener technologies is going to become important. That is the use of batteries is a problem with every industry at the moment. So we do need to work out a way to fix that part. But that's probably the biggest part. But just have to keep in mind as well that the manufacturing process, we need to decarbonize as well.
They ask also if there's a kind of atmospheric pollution. Do you think that could be an issue, or it's not that a problem?
We discussed this about this for the couple of days, and we don't see a lot of sources of atmospheric pollution. The only source of contamination at the side was maybe with the manufacturing of the battery. But for atmospheric pollution, since it's easier to undeploy them and for maintaining it, we don't think there's a lot of sources of pollution.
Okay. And we have someone that asked about the fact that the platform uses solar energy. What kind of power backup do we have in these kind of platforms? Maybe you already mentioned it based on batteries, no? I would say.
Yeah, I think the backup mechanism would have to be batteries. Like you can almost picture a HAPS system up in the air, and it goes to nighttime. Obviously, you're not going to have the solar powers coming from the sun anymore. So you're going to need something to work when the sun is out of reach. I think you do need a battery in some circumstances, unless you can somehow harness other atmospheric conditions into your own energy set. But I've only seen Formula One do that so far.
And some delegates state that most applications will be military, but I think you have already proved that there will be actually other uses, and this platform could be moved to other sectors, as you already mentioned.
Yeah. Actually, there are a couple of projects from the IT giants. Google is having Solara 50. Facebook is having a project for HAPS, and it's basically for internet connectivity. Now, this started before the mega constellation of satellites started from SpaceX and OneWeb. But it will be interesting to see how the competition goes along. Because that was the main idea for Facebook's project, providing internet accessibility to areas which is very difficult from terrestrial network. And as I said before, as with any new technology, it gets proven in the military sector where there's a lot of funding, kind of like GPS, and then it goes into commercial sector. So it will definitely come, but it has to prove itself in the military sector as well. Yeah.
And we have a question about, I think you had a slide dedicated to that, but maybe you can complement a little bit more. What's the trade-off to be done in order to decide we use hubs or we use satellites, small satellites, depending on the application and the mission requirements?
Yeah, I think it's the weight. It's the specific use case. What are you trying to do with it? How much equipment do you need up there? Some things might be better for a satellite to do if you don't have a massive requirement for 24-hour monitoring, 24/7 monitoring, let's just say. Whereas if you do need that, you would need that HAPS device, a HAPS system, there as well. Keeping in mind it's stationary, so you do get that. But yeah, the fact that you got satellite rolling around the Earth, there'll be different use cases. I would say highly dependent on that, the specific use case, why you need it, how often do you need it. Keeping in mind that, given these are stationary, if you do want to have a bigger area, you might have hundreds up there, different type of congestion.
Okay, and now let's do a last question, maybe out of topic, but you work together with people all around the world during all the sessions. How was your experience, and also the fact of having the possibility of work together with experts from GMV, as it was the case with Miguel Angel Molina? Could you say your experience so that maybe people watching this video could imagine how it was and will be motivated to participate in future editions of the European Space Generation Workshop?
Yeah, sure. I think it's not in terms of diversity, not only in terms of countries, but in terms of technical background. I think there are people from all backgrounds, and that always helps to bring in creative ideas, definitely. So yeah, it was totally an enjoying experience and a learning experience, definitely working with all the working group members. But as talking about the expert, I think it always helps because all of us are kind of on the same level. We are, young professionals and just making our way into the industry. So having an expert who has been working on this for 20 years, 30 years, I think, I think that helped for me.
And Dash, let's remember that Dash is in Australia, where most of people are in Europe. Could you just, to finish, give your vision about the workshop?
Yeah, no, it's been a great couple of days. The best part is probably Australia is still coming up. There's still a relatively infant in the bigger scale of things. So being able to participate in this, you've got the Miguel and you've got everyone else in the team. You're getting a lot more insights that you just wouldn't get being isolated, or not isolated, but being in Australia, given that we are coming up. So that really broadens it. And I'll admit, I didn't know too much about the HAP system before this course, but having access to the subject matter experts, but also everyone else is also a subject matter expert in their own right, actually helps you understand how much there is to go, how much more opportunities there are. So I'd say it's just that. It's really the ability to unlock a whole bunch of stuff that you thought you might have known everything, but there's always more there.
Thank you very much, Dash. Thank you very much, Gurav. Thanks to all the delegates again that participated in this working group, and also especially the sponsor GMV that made this working group possible. See you now in the next, we have a break now, and then we move to the next presentation, working group 3.
Thank you.